Welcome to A&Ls. Every day we go to work to achieve our vision. 0 injuries to hands and feet. The objective of this video is to create safe solutions in an area where there can be terrible injuries. Hazardous chemicals. Right now there are 145 million known different chemicals on Earth, each with an individual CAS number. Examples of hazardous chemicals are adhesives, cutting fluids, oils, and detergents. It's not possible to completely eliminate the risks, but it is possible to reduce them. In this area, knowledge is essential to get the right protection. Knowledge of how the chemicals react, e.g. on the skin. Knowledge of different materials' ability to stop chemicals, and knowledge of how protective products should be used to work properly. If you handle oils and other chemicals without protecting your hands, you're exposing yourself to risks not only to skin damage, but also damage to your nervous system and vital organs. You also risk developing skin irritation, oversensitivity, and corrosion damage because of the chemicals. The skin is the largest organ in the human body, and it's not impervious. Many chemicals are liquid, and it is therefore common to believe that they should react the same way as common liquids like water do. But they don't. Many chemicals react in a very hazardous way. It is important to separate 3 different reactions. Penetration involves the chemical moving through pinholes and other imperfections in the material. Permeation is a process whereby the chemical is absorbed into and passes through the material at a molecular level, and is therefore not visible to the naked eye. And in many cases, permeation is not at all discovered until it's too late. Permeation is known as the silent killer. We filled this balloon with petrol and tied it carefully. Nothing is leaking from the balloon. But after a while, we can smell the petrol and we can feel on the balloon's outside that it's oily. The chemical has permeated the balloon material. The time it takes for the chemical to permeate the material is called breakthrough time, abbreviated BTT. In A&R's laboratory, there is equipment that measures permeation for various chemicals, and we can provide you with calculated permeation breakthrough times. We can therefore always help you with information about this important aspect of a chemical's properties. Degradation is when the material's physical resistance deteriorates under the influence of a chemical. The chemical can cause the material to swell, harden, wrinkle, change color and shape, for example. When choosing chemical protection gloves, it's important to consider penetration, permeation and degradation of each chemical. It's also important to consider that mixing chemicals can have unexpected results. Before using new gloves, always visually inspect them for holes or other damage. Since the number of chemicals marketed is huge, it's virtually impossible to test all conceivable combinations of them. Models do exist for estimating combined effects based on what is known about the component chemicals. However, they presuppose that data is available and that the various chemicals involved have the same mechanisms of action. This means that the models can only be used for groups of chemicals that act in a similar way, not for the complex mix of chemicals that we are exposed to in reality. When it comes to protective gloves, there are 2 important factors that determine the glove's protective ability. The first and most important is the glove material. The second is the thickness of the material. A&R's chemical gloves are made of materials such as nitrile, neoprene, latex, and vinyl. The different materials protect from different chemicals. Always use our chemical protection guide that you find on our website, A&Ls.com. Consult with our sellers or send a request to us when choosing gloves. All A&Ls chemical gloves are tested and approved according to EN 374, chemical and microorganism risks. The second factor that determines the glove's protective abilities is the thickness, and thereby the breakthrough time. Breakthrough time is the time when a chemical is considered to have passed through a material. It depends primarily on the material and secondarily on the thickness and other factors. The thicker the glove, the longer the breakthrough time. This measurement determines how long the glove can be used before it must be discarded. Contact us and tell us which chemicals you want to use and under which conditions. We have BTT information for every chemical protection glove in our range. Remember that higher temperatures shorten the time it takes for the chemical to break through. Always use our chemical protection guide. Consult with our sales staff or send us an inquiry if you're unsure and need help choosing the right chemical protection glove. For complex cases, for us to be able to recommend gloves for chemical protection, we need to know what chemicals are handled. Please attach their safety data sheets. How are these chemicals handled? Please describe the work operations, duration, and level of expected exposure. In conclusion, it's not possible to completely eliminate the risks of hazardous chemicals, but it is possible to reduce them. It is important to know penetration, degradation, and above all, permeation, the silent killer, for the chemicals you work with. It's also important to know how different materials in gloves resist different chemicals, as well as what breakthrough time the chemical has for different materials and different thicknesses. Finally, always use the glove correctly. Contact us and we will help you choose the right glove so you're always protected when working with hazardous chemicals.